Welcome student, how are you? I am dear MAJHI, teach physics for you. Today I will be discussing the displacement of SHM or equation of SHM. Now let's start. Look at this. Look at this. This is a pendulum. This is to and fro motion. What is the property of this motion? The characteristics of this SHM, the force acting towards the mean position. That is, its motion always directed towards the mean position. Now, what is the definition from this condition? If force acting on a particle is directly proportional to displacement and directed to a fixed point. Look at this. Suppose this is the fixed point. The force directed along this direction, and this force is directly proportional to displacement. Then the motion is called SHM. Therefore, if F be the force, X be the displacement, then F proportionate minus X. Okay? So, F equal to minus Kx. Now, according to Newton's second law of motion, force equal to mass into acceleration. So this is the m into a equal to minus kx. Therefore a equal to minus k by m into x, where omega equals to root under k by m is called angular frequency. The equation 1, a equal to minus omega square x, is called acceleration of SHM. We know a equal to d square x by dt square. Now putting this value, we get d square x by dt square plus omega square x equal to 0. This equation is called differential equation of SHM. Solution of this differential equation is x equals to a1 cos omega t plus a2 sin omega t is called equation of SHM, where a1 and a2 are arbitrary constant. Now this equation is converted as x equals to a sin omega t plus phi, where capital A equals to root under of a1 square plus a2 square is called amplitude of SHM. Amplitude is the distance between mean position to extreme position, and phi equal to tan inverse a1 by a2 is called initial phase, and omega t plus phi is called total phase. If the motion start at mean position, then phi equal to 0. Therefore, equation of SHM, x equals to a sin omega t. Okay, and if the motion starts from extreme position, then phi equal to pi by 2. Therefore, this equation in term is a sin, this is the omega t plus pi by 2. Okay, therefore x equals to a cos omega t. So we get 4 relation of displacement. Now first of all, x equals to a1 cos omega t plus a2 sin omega t, where a1 and a2 are arbitrary constant, and x equals to a sin omega t plus phi, where capital A equals to root under a1 square plus a2 square is the amplitude of SHM, and phi is the initial phase equal to tan inverse a1 by a2, and finally x equals to a sin omega t if the motion start at mean position, and x equals to a cos omega t if the motion start at extreme position. Now we draw the two graphs of x equals to a sin omega t and x equals to a cos omega t with time t. Look at this. This graph is the x equals to a sin omega t. This is the sine curve, and this is the x equals to a cos omega t. This is the cosine curve. Okay, and this is the amplitude of oscillation, and this is the amplitude of oscillation. Okay, understood? Now I will be solving some numerical relating to SHM. Look at this. X equals to 5 bracket sin 3 pi t plus root 3 cos 3 pi t centimeter is the equation of SHM. We have to calculate amplitude and period. Now look at this. The formula is, if x equals to a1 cos omega t plus a2 sin omega t is the equation of SHM, then amplitude A becomes a1 square plus a2 square root under, and period t equals to 2 pi by omega, where omega is the angular frequency. Okay, now look at this. We compare this equation with this. Now look at this. The coefficient of cos is a1. So look at this. This is the a1. And coefficient of sine is a2. So this is the a2. So this is the a2. Okay. Therefore, amplitude of oscillation A equal to root under of a1 square plus a2 square. Okay. Look at this. a1 5 root 3 whole square. So this is the 75. This is the 75, and this is the a2 square, that is a 5 square, so 25, therefore 10. So 10 centimeter is the amplitude of oscillation. Okay, look at this. This is the angular frequency. This is the angular frequency. We know that time period t equals to 2 pi by angular frequency, therefore t equals to 2 pi divided by omega, therefore 2 pi by 3 pi, that is the 2 by 3 seconds. Okay, understood? Look at this. X equals to 0.2 sin pi t plus pi by 4 meter is the equation of SHM. We have to calculate amplitude, period and initial phase. Look at this. If x equals to a sin omega t plus phi, the equation of SHM, so this is the amplitude. Okay, this is the amplitude. And look at this. This is the angular frequency. Okay, and this is the initial phase. Okay, now the coefficient of sine is the amplitude. Now look at this. What is the coefficient of sine? Is the amplitude. What is the angular frequency? This is the omega. And what is the initial phase? Initial phase is the phi. Okay, therefore amplitude A equal to 0.2 meter. Okay, now time period t equal to 2 pi by omega. Now omega equals to pi, so time period t equal to 2 pi by pi equal to 2 seconds. Okay, phi is the initial phase, so here phi equals to pi by 4, therefore initial phase equal to pi by 4. Okay, understood? Find the time required to move from mean position to extreme position. Mean position to half of the amplitude, and time required to move from half of the amplitude position to extreme position. Okay, the distance traveled in one period is equal to this to this, then this to this, then this to this, and finally this to this. So A 4a. So time required to cover the distance 4a is the t. So time required to move from x equals to 0 to x equals to a, that is t by 4. When the motion starts from mean position, the equation of SHM x equals to a sin omega t. Therefore here x equal to a by 2. If x equals to a by 2, we have to calculate the t. Now from this equation, look at this. This is the a by 2 equals to a sin, this is the omega t. Now half equal to sin omega t, therefore sin omega t equal to half equal to sin pi by 6. Okay, therefore omega t equal to pi by 6. Now look at this. This is the 2 pi by t into t equal to pi by 6. Therefore t equal to t by 12. So time required to reach from x equals to 0 to x equals to a is t by 4. Now look at this. We already calculate the time required to reach from this position to this position is t by 4. Time required to from this position to a by 2 position. Look at this, a by 2 position is t by 12. So time required to reach from this position to this position is t by 4 minus t by 12, that is the t by 6. Okay. So time required to reach from this to this is t by 4, and this is the t by 12, and this is the t by 6. Okay. The equation of SHM is 10 centimeter, period 4 seconds, and the motion starts at x equals to 5 centimeter. We have to calculate the equation of SHM. Now the given quantity, look at this, the formula is x equals to a sin omega t plus phi is the equation of SHM. Now here the given quantity is a equal to 10 centimeter. Okay. Now t equal to 4 seconds. Therefore omega equals to 2 pi by t, that is 2 pi by 4. So this is the pi by 2 radian per second. Okay. Now finally the motion starts x equals to 5 centimeter when t equal to 0. Now we have to calculate phi. If we put this value in this equation, we can get 5 equal to 10 sin omega. Omega means pi by 2 into 0 plus phi. Then we now equation of SHM, x equals to a sin omega t plus phi. Sin omega t plus phi. Now we have to calculate phi by from this condition. Look at this, this is the 5 and a equals to 10, and this is the sin omega means pi by 2 into 0 plus phi. Therefore look at this, 5 by 10 is equal to sin phi. Therefore phi equal to pi by 6. Okay. Therefore required equation of SHM, x equals to 10 sin omega equals to pi by 2 t plus pi by 6. Okay. This is the centimeter. This is the equation of SHM. Okay. Don't forget to subscribe my channel for new videos. Okay. Thank you.